okay. It's pretty good.
You always get crazy, bro. You're like 3,000 hours per straight. On top. He's offing, wait for the tag. I probably have all of it here. I don't have to commit. It's just let me hold for a minute. They'll peek me with that off. Did it dart not go off? I say we do it again. They're gonna think that we do it again.
I saw something in the push. You can
Yeah,
push
you
me.
can just play like not like I think we can send the cobalt in. Dude, why is my Reyna AFK every round? Just jump peeking? You really can't.
CTC.
He's so mad.
Under.
Never.
What happened?
No. My Reyna stopped it.
Go ahead and run this. We'll see what we get. It's gonna. Hello everybody. In this lesson, we're gonna be taking a look at group by and order by in MySQL. Now, when you use the group by clause in MySQL, it's gonna group together rows that have the same values in the specified column or columns that you're actually grouping on. Once you group those rows together, you can run something called an aggregate function on those rows. Let's see how this actually works. Let's go ahead and copy this right here, bring that down, and we go back up one. Let's go ahead and write gender right here. Now, we want to group on this gender column, and we're going to say group by gender. Let's go ahead and run this. We'll see what we get. And so we have male. And female. Now, we could get the exact same output by saying select distinct gender from this table. What is group by doing that the gender actually isn't doing? Well, it's actually rolling up all of these values into these rows. So later when we run aggregate functions like average, min, max, we'll do it based off of these rows, and all those rows are rolled up into these two rows, and we'll see that in a little bit. Now, what if I was to come up here, and in this demographics, we have a first underscore name. What would happen if I'm selecting the first name, but I'm grouping by the gender? Let's go ahead and run this. If we come right down here, we pull this up, you can see that the select list is not in group by clause and contains non-aggregated columns. What this means is that when you are selecting a column, if it's not an aggregated column, like say average of something, if we're not using the aggregate functions in this, the select statement, it has to be in the group by. These have to match. So this gender has to match this group by if we're not performing an aggregate function on it. Let's go ahead and run this. And now it works properly. Now let's go back up. Let's run this query because I want to select everything again. Well, let's say we wanted to take a look at the average ages for gender. So what we're going to do is we're selecting gender. We're also grouping by gender. But what we're going to do is add a comma, and we'll say the average, that's AVG, that stands for average. And then we're going to put in here age. So now this right here is an aggregate function. This does not need to go in the group by. We're just grouping on the gender, and then we're performing this aggregate function, or kind of a calculation based off of those grouped rows for gender. So let's go ahead and run this and take a look at the output. So what this is telling me is that for the males, all of the male rows that were grouped, the average age is 41 point, let's say 3. And for female, the average age is 38.5. So super quickly, you can tell that the average age of females is lower than the average age of males. Now we'll take a look at aggregate functions more in just a little bit. Let's actually go to a different table. Let's come right down here. We're going to go to the salary table and just select everything for now. Go ahead and run this. Now, what we're going to actually be grouping on is this occupation right here. Now, there's a lot here, it's a little bit. Let's actually go to a different table. Let's come right down here. We're going to go to the salary table and just select everything for now. Let's go ahead and run this. Now, what we're going to actually be grouping on is this occupation right here. Now, there's a lot of unique values. It's not as distinct as the gender, which only had 2 values. You'll notice we do have a few that are the same. We have ones like office manager. So when we come up here, we're going to say occupation. And of course, we need to group by the occupation as well. Now let's run this. You'll notice that office manager only has 1 row. Let's say we also want to group on the salary. Let's say salary. Now we can group on multiple. So we're going to say salary like this. So we're grouping on the occupation as well as the salary. Now let's run this. You'll notice that we have 2 rows for office manager now. This is because this salary and this salary for those 2 employees are different. We have 50,000 and 60,000. For this, I just wanted to demonstrate that if these had both been 50,000, there would only be 1 row, office manager 50,000, but because this is a unique value, different than 50,000, they have their own individual rows, which we would then perform our aggregate calculations on. Let's go ahead and get rid of that because we will not be using that anymore. I just wanted to demonstrate it really quickly. So before we were looking at gender and average age, and we were also grouping on the gender. We can perform other aggregate functions as well. Let's take a look at some of those. We could look at the max age as well. The max is going to show us the highest value within each of those groupings. So we have a male and female. The max age for those, for the male is 61, and the highest age for the female is 46. We can do the exact same thing, except we can say min, or the exact opposite thing. We can say the minimum age. So this is going to be the lowest for both the male and the female. Go ahead and run this. Now we have female and male, and the minimum. Minimum age is 29 and 34. And there is one last one that I want to show you, which is count. We're going to do count. Now count is going to count the actual rows within this age column. So if we run this, you'll see that we have 4 females, for count, and we have 7 males. It's just telling us a count of how many values is in this column when we're actually grouping on the gender. So that's how we can use group by to actually roll up and group all of these similar values within a column or columns and perform our aggregate functions on them. Now let's come down here, and what we're going to take a look at is order by. So I'm going to say order by. Now, group by to actually roll up and group all of these similar values count for gender. Now, let's actually pull in this demographics table right here. We're just going to say select everything and run this really quickly after we add a semicolon. So order by. Order by is going to actually sort the results set in either ascending or descending order. Let's take a look at how this works. At the very end, we could say order by, and we could order by the first underscore name. So we're going to take this column, and we're going to order all of our rows based off of this one column. Let's go ahead and run this. So it's going to do it based off ascending order, which means smallest to largest. Now this is a text column or a character column. So we do it to Z. So Andy and April all the way down to Tom. Now by default, this is in ASC order, ascending order. And if we run this, it's going to be the exact same output. But we can change this to do it the opposite, highest to lowest, or Z to A, by doing descending. So now if we run this, you'll see that it goes Tom all the way down to Andy. Now let's take a look at ordering on something like gender and age, because we can do both at the same time. So let's order by the gender first. Let's go ahead and run this. And you'll see that all the females are grouped together and then all the males are grouped together because that's just the order in which it is. But we can do an additional column. We can also do it based off of the age. Let's go ahead and run this. So now within the female, since that came first in our order by, we're ordering by the gender, and then we're also ordering by the age after we've ordered by the gender. So now it's 29 all the way up to 46, and then 34 for males all the way up to 61. Now we can change this just for the age. Let's say we want to do age descending. So gender will stay the same in ascending order, but now age will be in descending order. Let's go ahead and run this. Now female and male stayed the same, but now it starts at the highest down to the lowest. Now this is something that I would absolutely do in real life, except sometimes you can make mistakes and sometimes you do the wrong column first. Let's do age, and then we'll do gender. Now, if we run this, the gender is not going to be used at all. And this is because there are no unique values that are going to be on the same row. So notice all of these values are completely unique. So the gender never is actually used to order anything on, because if there were things like 34, 34, 34, 34, these would be ordered based off of the gender. But since there's no unique fields, this is really pretty useless. That's why the order of the order by, or the columns that you place in the order by, are actually quite important. Now the last thing that I want to show you, and I'll just go back to gender and age, is that you don't actually have to use the column names. We can use the column positions. Now, I will preface this by saying I don't recommend doing this, but I sometimes do it in shorthand for just a quick query if I know the column position and I don't want to write out the whole name. Sometimes I do it, although it's not best practice. But let's take a look at it. So gender is the 1, 2, 3, 4, 5th column. I'm going to replace this with 5, and age is the 1, 2, 3, 4 column. So these are the positions of the fields, but not the names of them. If we run it, we're going to get the exact same output because these represent these columns appropriately. But again, I just don't recommend it. It's kind of a slippery slope that I've fallen down myself many times. And when you get to more advanced SQL and you're creating things like stored procedures and triggers and all these things, this can actually cause a lot of issues. If you were to add any columns or remove any columns, then you'd be ordering by the wrong column because let's say this last name got removed, we didn't want it for some reason, then the gender is 1, 2, 3, 4. Now we're ordering on the wrong column, and that would be a big mistake. So just by best practice, it is better to do gender, age, but I just wanted to show you that in case you want to be like me and kind of go down the wrong path. So that is everything we're going to take a look at with group by and order by. In the next lesson, we're going to be taking a look at having versus where. Hello everybody. In this lesson, let's take a look at it. The names of the time. There are no, now age will be in.
Oh,
CP.
Just beyond.
Basic things that you should be grateful for. That was like the qual. Anything else?
Down mid.
No, you want to play? Let's play.
Time one. They're not committing. That would kind of fade. I have ult for retakes.
Spike down A.
There they are.
Can we hold cross?
I'm gonna ult. Close. Short and long. Oh, 80 Silva. I have a drone.
Deploying drone.
That's long, Silva's in that smoke. Might go short, I guess.
30 seconds left. One enemy remaining.
Probably left, I guess.
Could wrap around.
What? Yo, Kenny with a 37 months. Let's go. W Kenny in the chat. Wow, 37 of them. What if my elo was a bank balance? What would I be eating? I'd be fucking. That's a great question. Probably like a big pile of fucking dirt. Why do they not listen to me? Oh god.
Descending order. Hello everybody, in this lesson, we're going to take a look at the difference between having and where. Now in the last lesson, we looked at group by and order by. The most obvious thing to do would be to come right here and say where, and we're going to say this column, which is actually named this, we'll say where the average age, let's say is greater than 40, which would only be the males. So let's go ahead and run this. And as you can see, we're not getting any output. Let's bring this up and take a look at the error. It says invalid use of the group by function. What's actually happening is something to do with this group by gender right here. When we're selecting gender and then we're performing an aggregate function, this occurs only after the group by actually groups those rows together. So when we're trying to filter based off of this column right here of average age, it really hasn't been created yet because this group by hasn't happened. That's where the having clause comes into play. So let's go ahead, and what we're going to do is we're going to get rid of this. We're going to come right down here, and instead of where, we're going to say having. Now, having was specifically created for this exact example. It comes right after group by, and after group by, we can filter based off of these aggregate functions. So now if we run this, we're going to get an output that only has where the average age is greater than 40. Now let's take a look at just one more example, and I'm going to show you how you can use both in one query. So instead of demographics, let's look at the salary table, and let's run it. Now, in this salary table, we have this occupation, and remember, we have this office manager that happens twice. And this is going to be our main example. So we're going to say occupation, and then we'll say the average salary. Now we'll need to come down here. here, and we'll say group by. Now we're going to say occupation. So this should look pretty similar because right here we have our office manager, and one of the office managers made 50, one of the office managers made 60, so the average is 55,000. Now I can use the where by saying where, then I'll say occupation like, and let's see people who are managers. So I'll say percent manager percent and close that quote. So they're like a manager. And then I want to see where a manager makes more than, let's say, 75,000. So I won't actually say where, I'm going to say having an average salary, and I need to add a space there, having an average salary greater than, let's say, 75,000. And let's run this. So now I filtered at the row level right here in the where clause, but then down here, I filtered at the aggregate function level. This having is only going to work for aggregated functions after the group by actually runs. So that is the difference between the having clause and the where clause. The where clause you're most likely going to use a lot more, but if you do want to filter on those aggregated function columns, you have to use the having clause. I hope that was really helpful. And in the next lesson, we're looking at our very last lesson in our beginners series. We're going to look at limit and aliasing. Hello everybody, in this lesson, we're going to be taking a look at limit and aliasing. Limit is just going to specify how many rows you want in your output. If we take this table, for example, if we come right here and we say limit, let's do 3. If we run this, it's only going to take the top 3 that we have. Let's go ahead and run this. As you can see, we have employee 1, 3, and 4. Leslie, Tom, and April. Now this seems super straightforward, really easy, but it can be combined with order by to actually be really powerful. For example, let's say we wanted to take the 3 oldest employees. All we'd have to do is come right under here, and we say order by, and we'll order by the age in descending order. So we're gonna order on age descending, and then it's gonna take the top 3. So if we run this, and very quickly, we have the top 3 oldest people in this table. Now there is one additional parameter that we can use in limit, and all we have to do to access it is have a comma here. Now what this is gonna do, and I'll put a 1 here. What this is gonna do is it's now gonna say, we're gonna start at position 3, and then we're gonna go 1 row after it. Now I actually wanna take one of these people, so let's start at position 2 and select the next one after it, which should be Leslie Knope. So we're gonna start at position 2, and we're gonna select the 1 right after it. So we're gonna start at position 2, and then 1 means we're taking the next 1 row. Let's go ahead and run this. And as you can see, we got Leslie Knope in our row. Let's go ahead and run this. And as you can see, we got Leslie Knope in our output. Now let's come right down here. We are going to now look at aliasing. Now aliasing is just a way to change the name of the column for the most part. And it can also be used in joins, but we're gonna take a look at joins or aliasing joins in the intermediate series. In a previous lesson, we looked at a group by that looked like this. We selected gender, and we said from, I believe it was employee underscore demographics. Then we said group by gender, and we also had the average, and I think it was age. There we go. And we'll add our semicolon. Let's go ahead and run this. In our output, we have gender as our gender column, the same as the column name, but then average age is average age. And so if we want to actually do something like a having, where we say having the average age, let's say greater than 40, like we had it, we have to actually use this aggregate function in our having clause, and we don't want to always have to do that. We can actually change the name of this column and subsequently use it throughout our query with that aliased name. So I'm going to say as, and that's the keyword to actually change it. We'll say as, and we'll do average underscore age. So now we've changed this name to average underscore age, and we can come down here to having and say having the average age greater than 40. And when we run this, it works perfectly, and you'll notice that the name of the column was actually changed. Now, this as isn't actually 100% needed. It's kind of implied. Even if we get rid of it, it's implied there's like this as in there somewhere. But we don't have to have it. If we took it out and ran it like this, it would still work exactly the same. So that is how we can use limit and aliasing in SQL. And congratulations, this is the end of the beginner series in MySQL. In the intermediate series, we're going to take a look at things like joins, unions, case statements, subqueries, and window functions. Hello everybody, in this lesson we're going to be taking a look at joins. Joins allow you to combine two tables or more together if they have a common column. That doesn't mean the column name has to be the exact same, but at least the data within it are similar that you can use. There are several joins that we're going to look at today, like inner joins, outer joins, and self joins. These are the two tables that we'll be working with the most throughout this lesson. We have the employee demographics table as well as the employee salary table. Now within the employee demographics table, we do have this employee ID column. And if we look at the employee salary, we also have the employee ID column. Now in this instance, the column name is actually the exact same, and of course the data inside of it is also very similar. So let's start by by writing out an inner join. This is probably one of the most common joins, one of the most simple joins as well. An inner join is going to return rows that are the same in both columns from both tables. So let's see how we can actually write out this join. Let's come right down here and let's copy this. This will be the first table that we start with, and then we'll join this salary table onto this demographics table. So what we need to do is we need to come right here and we need to say join. Now by default, join represents an inner join, although we can write inner join here to make it more explicit, explicitly writing out inner join. Then we're going to come up here and we're going to say employee salary. So we're selecting everything from the employee demographics, and we're doing an inner join on the employee salary. Now we have to tell MySQL exactly what columns we're supposed to be joining on. I'm going to hit enter and I'm going to hit tab. Now you don't have to hit tab. It just looks more code-like and it's easier to read, and that's how I've done it for other programming languages as well. So that's how I'm going to show you how to do it. What we need to do is say on. Now this keyword is going to allow us to say we're joining the demographics table to the salary table based on these two columns. So from the demographics table, we're doing the employee underscore ID is equal to, and then in the salary table, it's also the employee ID. Let's do employee, now you spell it right, employee underscore ID. Now, if we try to run this, and let's do this, we're going to get an error. And let's bring this up. It's going to say column employee ID on the in clause is ambiguous. Now, what does it mean ambiguous? That means that it doesn't know what table this employee ID is from. Is it from the employee demographics table? Is it from the employee salary table? We don't know because it's ambiguous. Now, what we can do is we can specify it by saying employee demographics dot employee ID, and then employee salary dot employee ID. Now, if we run this, we're going to get the output that we're looking for. And let's take a look at this real quick. Let me bring this up. So we're pulling everything from the employee demographics, that's right here, all the way through the birth date. Then we're pulling the employee salary table. That's the employee ID all the way, let's scroll over, through the department ID. So we're basically pulling in all of the rows or all of the columns from both tables, but we're not pulling in all of the rows. Remember, an inner join is only going to bring over the rows that have the same values in both columns that we're tying on. So in this employee ID, we're missing number 2. Are we missing any other ones? No, we're only missing number 2. Let's go back up and I'm going to run both of these tables and we're going to take a look. So let's run this. So you'll notice in the employee salary table, we have a number 2 right here, and that's Ron Swanson. But in the employee demographics table, we don't have that. I believe that Ron Swanson did this so that Leslie Knope would not know when his birth date was because he didn't want to bring that information. I think that makes the most sense, although Ron was not willing to give information. I think that makes the most sense, although Ron was not willing to give a comment on that. Now, if we run this again, you'll notice that 2 is not in there. Since 2 is not in the employee demographics table, the employee ID 2 is not going to be populated or brought over into this output from the employee salary table. Now, really quickly, this is honestly giving me some anxiety because this is so incredibly long. Something that I mentioned in the beginner's series is that you can use something called aliasing when using joins, and that's really helpful. This is what I mean. So right here we have employee demographics. We're going to call this DEM. You can also do as DEM. You can do as SAL. These are just short names for demographics and short name for salary. And we can replace these and say DEM.employeeID and SAL.employeeID. Oh, that looks so much better. Now we're going to run this and it'll be the exact same output, but now we're using these aliases, which just makes it so much easier to read. Now, one last thing that I want to show you while we're just looking at the inner join is selecting the actual columns. let's say we wanted to select the employee ID, and we wanted to select age, and then we wanted to select their occupation. If we try to run this, we're gonna get an error, and it's gonna be almost the exact same error that we got before, which is column employee ID in field list is ambiguous. So in our field list, which is right up here in the select statement, we have this employee ID. It does not know which employee ID to pull from, whether it's the demographics or the salary. So we have to tell it which one to pull from. So let's pull it from the demographics by saying dem.employee ID. Now when we run this, we're able to get information from both tables in our output without having all of the information. And if there are columns that are similar in both tables, we have to denote that by using this alias or the table name. All right, so that is inner joins. Now let's move down here. I'm gonna copy this and we're gonna come right down here and we're gonna look at outer joins next. And let's put that right here. Now for outer joins, we have a left join and we have a right join, or a left outer and a right outer join. A left join is gonna take everything from the left table, even if there's no match in the join, and then it will only return the matches from the right table. The exact opposite is true for a right join. Let's see how this actually works. Let's start by changing this to a left join or a left outer join. They're both the same and you can use them similarly. I'm just gonna say left join, and we're joining it on the exact same things. And I'm gonna take everything, so I think that'll be easier to visualize. And I'm gonna run this. Now you may notice that this looks exactly the same, and that's for a very good reason. It's because in the left table, which is the employee demographics table, the from statement, that's our left table, and then the join, where we're actually joining on, that's our right table. So this is our right table. So since we're doing a left, it's taking everything from the employee demographics. Now remember, the employee demographics didn't have Ron Swanson. It had no information. So everything in the right table had a match. Well, let's change this to a right join. And what this is gonna do, and I wanna make it all cap, make it all the same. What this is gonna do is it's gonna take everything from the employee salary table, but if there is not a match in the employee demographics, it just will have nulls. Let's go ahead and run this. So now it looks a little bit different. Now we're taking everything from the employee salary. So we're taking Ron Swanson, but if there is not a match, it will still populate that row, but it'll have all nulls in it. Then any of the information that is overlapping or the same, it will bring over. So employee ID is matched to employee ID 1. Then we'll bring all that information over from the left table. And that's essentially what a left and a right join is. With a left table, you're taking everything from the left table and then matches from the right table. If you do a right join, you're taking everything from the right table, but only matches on the left table. And again, it populates it with nulls. Now let's go down and look at our last type of join that we're gonna look at. And this is a let me spell that right, a self join. Now what is a self join? It is a join where you tie the table to itself. Now, why would you want to do this? Let's take a look at a very serious use case. Let's do select everything. Let's do this from employee underscore salary. And let's run this. Now let's say it's December 1st and the employee and Rex department decided to do a secret Santa. And they wanted to assign, based off of their employee ID, the person who they're gonna have as a secret Santa. We can help orchestrate this very easily using MySQL. Well, very easily is subjective, I guess, but let's take a look at how we can do this. So just like any other join, the first thing we're gonna do is select everything from employee salary and then say join, and then we're gonna say employee salary again. So we're tying it to itself. Now, when we come down here, and let me do this. When we come down here and we say on, we have to specify which table we're pulling from. Are we pulling from the left table, which is like the first table we're pulling from, or are we pulling from when we're joining on the right table? We need to be able to distinguish these two tables because they are the same. So I'm gonna say EMP1, and I'm gonna say EMP2, just to say this is employee table 1 and employee table 2. So we're gonna tie them based off the employee ID because we know those will be the exact same because we're pulling from the same table. So we'll do EMP1 dot employee. And just so you know, if it populates like this, you can hit tab and it'll auto finish that for you. And EMP2 dot employee underscore ID. Now, if we run this, let's do this. The output that we're going to get is literally just a 1-for-1 match. It's all the columns and all the rows because they all match exactly. But now what we're going to do is we're going to assign an employee ID to the next employee ID, and that'll be their secret Santa. So just keep it really simple. The next highest person with an employee ID, that is their secret Santa. So let's do an employee ID plus 1 is equal to employee2.employee ID. So we're adding 1 over here, and we're saying that's equal to this employee ID over here. Let's run this. So now you can see Leslie Nope is now going to be assigned to Ron Swanson, who has an ID of 2. Ron Swanson is going to be assigned to Tom Haverford, which I'm sure he's really happy about, and so on and so forth. Now let's bring this down here. And what we're going to do is try to simplify this and simplify this output a little bit, because this is a little bit chaotic down here. So we're going to specify what columns we want in our output. What we're going to want is the employee ID, first name, last name, and then employee ID, first name, last name of the person who they got for Secret Santa. So we're going to start with emp1.employee_ID, and we can call